What other differences have we noticed about artificial versus natural? Well, we know that there are some issues with ball roll and bounce, with slightly more roll resistance on football turf. The second bounce is not the same on football turf. Less stability during turning, anecdotal evidence from top-level players. Increased muscle soreness and tiredness, especially in the lower back, groin, and ankle. These are questionnaires gathered by a professional group called FIFPro, Professional Players Association. They send questionnaires to the professional cohort, and that's some of the conclusions that are drawn. But there are also reports of no adverse performance or health effects of the two surfaces, health differences. So it's still up in the air. It's definitely open for research. This is something we're going to be looking at because when you perceive a surface is unstable, and if you're slipping, muscle activation increases. That's pretty accepted in the literature. Particularly for turning, you would have increased muscle activity in the lower back, groin, and ankle, the muscles around the ankle. So what we're talking then is subtle differences, something that might be able to be detected not using heart rate, not using other physiological measures, but you would be able to pick it up with things like muscle soreness and those sorts of parameters to the next day or 2 days later. Implications could be for recovery from training. If you've got a match 2 days later, you may not be keen to train on an artificial pitch and risk muscle soreness bang on match day, for example, if the research leads us in that direction. What are we doing at the moment? Well, we're looking at systematic changes in surface properties of artificial turf and trying to look at some of the parameters that we've measured outdoors and trying to build up criteria to assess the surface. Stuff that eventually we'll be able to give as feedback to manufacturers and to perhaps one day to players and coaches. That's far off. But in the first instance, it's giving more information about what's happening and how the surface can be improved to perhaps be a better mimic for natural turf. And then there'll be ongoing work to quantify body load during repeated turning maneuvers, quantify it in regard to long-term fatigue effects, or fatigue effects that will last in subsequent days, perhaps. Just want to acknowledge that this work was funded by FIFA as part of their efforts to ensure high-quality football playing surfaces worldwide. Thank you.
Thank you, Mark. So this paper is open for questions. Any question from the floor? Yep. Well, okay, yeah. Okay.
Peter
Go.
Donoghue,
Yeah.
University of Wales. I was interested in the notational analysis study that you referred to that gave an indication of the number of V cuts and other cuts. Using probably a different method, we found that there was actually only 20 V cuts performed in a match by 180 different Premier League players, compared with more like 75 cuts that would be of about 90 degrees.
That's useful information. That sounds like a more thorough job than we've done. We base that on digitized player cam data, but we don't have as nowhere near the magnitude of data that you have. If we had access to your data, we might have a different opinion.
Yeah, the study I'm referring to, it's just been accepted sometime over the next 3 months, it'll be in the International Journal of Sports Medicine and Physical Fitness. What you've just described may be more thorough than what we've done. We used Prozone data, and it was an automatic algorithm that I wrote that basically does this. But the thing is, if you have more than one cut in a second, it won't see it. And when you look at the video, you will see players doing things. So I think there's a lot of strength to the method you've just described.
Okay. Next question. Yeah, you all.
Errol Hennig from Essen, Germany. Mark, very nice presentation, really enjoyed it. One of the data I'm missing is the performance, because we know depending on the surface, players would approach differently. So if you do a maximum 135-degree turn and you have more confidence that you will have the traction, you might increase supination. So it actually might be a performance criteria rather. And you might, of course, go the risk to have a greater injury risk. So you said that you also did some measurements on performance, like a function tracking test or something like this. You find differences, or did the players report differences in how they liked the serve, or was it pretty much the same?
Yeah, the only measurements that we did were we did other measurements, a part of the study, which was shock absorption, landing from jumps, and kicking. But in terms of the cutting and turning, we asked the subjects to approach with 80% speed. So it wasn't maximal, and we asked them to try to maintain that the same across all the different pitches. We measured the approach velocity, and although we didn't tightly control it, if they were slightly fast or slow, we didn't say, right, that's a bad one, do it again. We measured what they did, and there was no significant difference across the different countries. We also looked in detail at the foot landing velocity, and we did find a slight decrease in foot landing velocity for the artificial surfaces. So I don't know why. I think maybe because it was perceived as being a slightly harder surface. But we got no such feedback from the players. Feedback from the players we got were that they really liked one particular football turf, and that was the floating surface that I referred to, where it actually gave a little bit when they landed. And they practiced that little bit, and they got used to the fact that the surface gave about ½ an inch each time. So, and that made them quicker. So there are those sorts of things there. But it was difficult to control approach speed, but as it turned out, it was no different anyway. So it's difficult running an outdoor study like that, but we decided that just to get them to try and judge to their best of their ability to try to keep a constant speed. And it worked out well.
Maybe one more quick. No? Oh, yeah, Mark. Yeah.
I know it's difficult when you have limited subjects and so on, but were you able to, linking with the performance thing, was there a difference within the athletes in the group that were the exceptional direction changes as distinct from the rest? So, you understand what I'm asking? So, yep.
Yeah, there were individuals within the group who would go in just slightly different directions, and overall there was no effect. We haven't fully analyzed what characteristics made specific subjects go in one direction or another. But certainly, in general, it's clearly no effect for a lot of the variables that we measured, except for ankle supination. That was clearly an effect. I was a bit bemused by that because we looked at peak acceleration of the rear foot as a measure of traction. And that didn't come out as different. So then I went one step further and started to look at the slope of the acceleration curve. But still, that wasn't coming out. There is some variability amongst the subjects, and there's variability within a subject. I think if the experiment was repeated in an indoor lab environment, where we can do more trials, slightly more experimental control, then I think some of those differences would become significant.
Yeah, thank you. I have a very quick comment. Our results seems very inconsistent because a larger deformation may induce larger supination during cutting. You agree that? Do you?
So you found the supination?
Yeah, large deformation of the surface may induce larger supination.
Yes.
Uncle.
Yes.
Yeah. Okay. Thank you very much again. So we have a last speaker.